Hi, in this video we will go through Chapter 7, Section 2, problem number 11, and this is finding the area of, or the volume of a solid generated by revolving a region. Okay, so in this example, number 11, we have that y equals square root of x, y equals 0, and x equals 3. That's the region for which we'll be bounded. If we look at that graphically, the black line here shows square root of x, the blue line shows y equals 0, or the x-axis, and then the red line shows x equals 3. Okay, so in the first problem, I want to revolve this around the x-axis. Notice that if I revolve this around the x-axis, it's going to be a solid. Okay, so I don't really have to worry about the inner radius. Let's go back and look at our formula. Our formula tells us that volume is equal to pi, and then the integral from a to b of our outer radius, that's capital R squared, minus our inner radius. The inner radius comes into play if we have a hole in the middle. So we want to know what the radius is of the inner hole. But in a solid generation, such as the one we have when we go around the x-axis, this actually becomes 0. So all I'm concerned with is the outer radius. Okay. So my volume in part A is going to be equal to pi, and now I'm going to integrate from A to B. I need to figure out what that is, and I need to figure out what the outer radius would be. So now remember, I'm just going to basically take this and revolve it around the x-axis, thinking about spinning this around. Okay? We talked about that it doesn't have a hole in the middle, so the inner is 0, but my outer radius is going to change along this curve, right? Up here it is square root 3, down here it is 1, right? Because when x is 1, this is square root of 1 and 1. So this actually changes according to my function, y equals square root of x, right? And now notice that my function is from 0 to 3, so that's what I'm going to integrate. So I'm going to integrate from 0 to 3, and then my outer radius, which we determined would be the square root of x squared. Okay? So now to do this, I get pi integral 0 to 3. Square root of x squared is just x. I forgot my dx. Okay? And so let's integrate that. I get pi x squared over 2, and that needs to be evaluated at 3 and 0. I get pi, plugging in 0, I'd get 0, so I only have to worry about plugging in 3, which is 9 over 2. Now let's do a different example where we actually rotate this around the y-axis. Again, let's go back to our graph, and now instead of thinking about flipping this down, we're going to rotate it this way. Notice in this example, I'm interested in finding the volume of this curve, or this area here, that's bound by this curve 0 and 3. So it's going to be this solid area in here. Okay, so when I revolve that, it's going to actually create a hole in the middle. Think about this as now being a funnel. Okay, I'm going to have an inner radius and an outer radius. Okay, so let's first look at what the outer radius would be. Well, as I revolve this around, this is going to be 3. So at the top of this outside part is going to actually be 3. Okay, so I know that my outermost radius is going to be 3. Let's talk about the inner radius now. Well, again, I can't just determine that that is just going to be one number. That's going to change as this goes down. Okay, so what are my radiuses here? Okay, they're going to actually, out to here, they're going to actually change every time. So now it's going to be a function of x. So I basically have to take my function, which is y equals square root of x, and solve that for x. I can do that by squaring both sides, so x equals y squared. Okay? So in other words, my radius is going to be here, y is 1, so the radius is going to be y squared is 1. Okay, here y is square root 3, so the radius is going to be 3. Or here y is square root 2, or the radius will be 2. Okay, so now knowing those things, okay, I can plug into this formula. I get pi integrated. Now I need to figure out what I need to integrate from. I'm not going along the x-axis, so it's no longer 0 to 3. I'm going along the y-axis, so it's 0 to this. Well, we know at x equals 3, this is actually square root 3. So that's what I'm integrating for. So 0, square root 3. My outer is going to be 3, so I'm going to take that squared and then subtract off the inner, which is y squared squared dy in this case. Okay, so it's going to be pi, and now I can just integrate this. This is going to be 9. The integral of that is just going to be 9y. This is y to the 4th. The integral of that is going to be y to the 5th over 5. Okay, and I need to evaluate that at square root 3 and 0. Okay, so we get pi, plugging in the square root of 3, I get 9 square root 3, and then subtract off, well, 3 to the 5th is going to give me 9 square root 3 over 5. Okay, and now when I plug in the 0, all that goes to 0. And now simplifying this, all right, getting a common denominator of 5 and adding these two together, my answer would be 36 square root 3 pi all over 5. So that's my answer. So we have two other additional problems. We want to see what the volume would be if we rotated around x equals 3. So let's go back to our graph, and notice here that we're talking about the region bounded here. So when we swing this around x equals 3, it's going to create, again, a solid object. There's going to be no hole. All right. So we know that the inner radius would be 0. What would the outer radius be? Now it's going to change across this entire thing, and you might think that that's just y squared, but it's not. It's going to be 3 minus y squared, because y squared gives us this radius, so it's going to be 3 minus that. Okay. So going back here, my inner radius, like we just talked about, is going to be 0, so I don't have to worry about that. But now the outer radius is going to be 3 minus y squared. So now we can find our volume. It's going to be pi. Again, I'm still integrating from 0 to the square root of 3 because I'm going in the y direction. And then I take that outer radius, which is 3 minus y squared squared dy. And I don't have to worry about the inner because it's 0. So from here, you just integrate this, expand it out, okay, integrate it, plug in your values, and you get the volume. And now for the last one, I'm not going to go through how to do that exactly. I think you can do that part. The hard part for these is actually getting them set up. So for the last one, let's look at when we're going to rotate around x equals 6. So we're going to be out here. Notice that we're still talking about this region in here, and we're going to swing it all the way around the x equals 6. So we're going to set it up a little bit like the last one we did. However, keep in mind we are going to have this hole this time, okay? Notice when we swung around here, it was one big object, so our inner radius was 0. But this time when we swing it around, we will have this hole here with radius 3, okay? Because 6 to 3 is 3. So that gives us a clue as to what our inner radius would be, okay? And now on this one, our outer radius is going to be very similar to what our outer radius was here. Here it was 3 minus y squared. When we move over to the 6, it's going to be 6 minus y squared. Okay, so now once again we can set this up as the integral from 0 square root 3, our outer radius squared, so that's going to be 6 minus y squared squared. Then subtract off our inner radius squared, which would be 3 squared, or 9. And again, dy, expand this out, combine your like terms, and then integrate and evaluate from square root 3 to 0. Hope this example helps. Let me know if you need more help.